In this video, I'd like to go over a brief trigonometry review. This is the second part of a two-part video series going over the math skills that you need in order to be successful in our course. So we're going to be dealing a lot with right triangles. So this is just a refresher that when you have a right triangle, which means that one of the angles is 90 degrees, then you have three sides. The long diagonal side is the hypotenuse, and then the opposite side is the side that happens to be opposite to a given angle, which is represented by theta here, and the adjacent side is next to the angle. So we have to know what these sides are called: adjacent, opposite, and hypotenuse. Now, if you had been given the angle over here, then this would not be the opposite anymore. This one would be the adjacent, and that one would be the opposite. Once we have a right triangle, we can use the Pythagorean theorem to solve for any of the unknown sides. So if you call one of the sides A and one of the sides B, then the hypotenuse, which we'll call C, can be solved for using the Pythagorean theorem, which is right here. And when you solve for C, you take the square root of both sides. So this expression here will give you the length of the hypotenuse. Let's go ahead and use the Pythagorean theorem to find the length of the hypotenuse of this triangle. So if we call this A and this B, doesn't matter which one's A or B, as long as it's not the hypotenuse, we call the hypotenuse C. Then we have the hypotenuse is the square root of A squared plus B squared, and this equals the square root of 8 squared plus 6 squared. This is the square root of 64 plus 36, which is the square root of 100, which is 10 centimeters. Since the original sides were in centimeters, the final result is in centimeters. But another reason for this example here is to let you know that this is actually a special type of triangle. It's called a 3-4-5 triangle. Whenever you have a right triangle where the sides have the relationship 3, 4, 5, so it can be like this one, it can be 6, 8, and 10, right? Those numbers are all a multiple of 3, 4, 5. They're just 3, 4, 5 multiplied by 2. It could be 3, 4, 5 multiplied by 3, right? 9, 12, and 15. Whenever you have a triangle that has two of these sides, such as 3 and 4, 6 and 8, 9 and 12, then the hypotenuse has to be a multiple of 5. So if it's 3, 4, it has to be 5. If it's 6, 8, it has to be 10. If it's 9, 12, it has to be 15. We don't really see this one very often, but we do see 3, 4, 5, and 6, 8, 10 pretty often. So this helps to save you time. If you recognize these sides as being part of a 3, 4, 5 triangle, then you can easily find a hypotenuse without having to use the Pythagorean theorem. Let's look at the trigonometric functions. So you may have learned SOHCAHTOA, perhaps in high school. This means SO means sine equals opposite over hypotenuse. So S for sine, O for opposite, and H for hypotenuse. So this is a quick way to remember that the sine of an angle is equal to the opposite over the hypotenuse. Likewise with CA, C is cosine, A is adjacent, H is hypotenuse. This helps to remind you that cosine of an angle is the adjacent over the hypotenuse. Likewise with tangent, tangent of an angle is the opposite side over the adjacent side. So if you remember these definitions, then they'll allow you to solve for some of the unknown quantities in your right triangle. Let's take a look here. Solve for the unknown side x. This unknown side is opposite of our given angle. This is the opposite side. And the given 9 meters here is adjacent. So what we do is we realize that we want to know the opposite and we know the adjacent. So the trigonometric function that relates to opposite and the adjacent is a tangent function. TOA tells us that the tangent of the angle is the opposite over the adjacent. So let's plug in what we know. Tangent of the angle is 21 degrees equals the opposite, which is x, over the adjacent, which is 9. I'll leave the units out for now. So now we can solve for x, multiply each side by 9. X equals 9 times tangent of 21 degrees. Plug this into your calculator, make sure that you are in degree mode, and you'll get about 3.5. Since this side was in meters, this means that the other side, x, is also in meters. So you can see how to solve for the unknown side. Just figure out which trigonometric function to use based on what you're given. Since we were given opposite and adjacent, we used tangent. If we had been given opposite and hypotenuse, then O and H, we would have used sine for so. So just to keep in mind, that's how you can use the SOHCAHTOA to your benefit. Let's do one final example. And this is looking at the inverse trig functions. Sometimes you have to get theta by itself. So if you know the sine of theta, then you can take the inverse sine or the arc sine of sine of theta to get theta by itself. So you can see that this inverse sine, also known as arc sine, gets rid of sine, and you're left with just theta. Likewise, you can use inverse cosine to get rid of cosine. You see you're left with theta. You can use inverse tangent to get rid of tangent. So we can see this in an example here. Solve for the unknown angle theta. We are given this side, which is adjacent, A, and this side, which is the hypotenuse, H. So whenever we have adjacent and hypotenuse, the trig function that relates these two, remember CAH from SOHCAHTOA, tells us that the cosine of theta equals the adjacent over the hypotenuse. Let's plug in what we know. Cosine of theta equals 12 over 18. Now we have to get theta by itself, so we're going to use the inverse trig function, the inverse cosine function. We have to apply it to both sides, and that will give us theta by itself. So this means that theta, right, the left-hand side is equal to theta, this cancels this out. Theta equals the inverse cosine of 12 over 8. Again, make sure that you're in degree mode in your calculator, and you'll get 48 degrees for theta. So that's all for these videos. Just a brief review of the math skills that you need in order to be successful in our course.